All right, three things that are going to help us before we start our first proof today, along with your knowledge. The first thing is, and I've been teaching this course for 21 years now, and I still have no good way of introducing this. Okay, it's called the reflexive property. And as you read this, you're going to be like, is this guy serious? A quantity is equal to itself. Ooh, mind blown there, huh? So what we're saying is, hey, line segment AB, guess what, everybody? It's the same length as line segment AB itself. And angle B, it's got the same degree measure as itself, angle B. That's called the reflexive property. I'm just going to let that sit, all right? Because by the end of class, you'll be like, I got it now. I got it. I know why we need this now. All right, but for now, let's just let it sit. And as I introduce it, you'll also notice it up on the whiteboard over there, all right, because we're going to have a lot of help over there for us. All right, so in addition to your own knowledge, I'm going to put all the helping properties up here as well. All right, these will be given to you on the test next week. All right, no need to memorize them, how to spell them. These will be given to you. You just got to know how to use it. All right, last year, you guys probably did a lot of substitution in algebra. Right? Remember these days? Find 3x minus 8 if x equals 12. And you took 12 and put it in, substituted in for x, and got the value of the expression. That was for algebra last year. We can also do it for geometry. We can do substitution. Take a look at my first example underneath substitution. Line segment AB. How long is it? Well, it's twice the length of line segment AD. All right? Line segment AB, twice the length of line segment AD. And in addition, I'll tell you, AD and DB are the same lengths. Using substitution, can we come up with a new statement that's also true? Using these two statements in substitution. Well, one more time, remind me, what's AD equal to? The same length as? So wherever I see a AD, what can I plug in for it? DB. So now confidently I can write that AB is also twice the length of what? DB, because I could substitute it in for AB. Everyone see the geometry substitution here now. All right, DB and AD have the same length, so I could substitute DB in for AD. All right, that's with me helping you. Now I'm going to do a couple in your group. Measure of angle A and the measure of angle B equal 90. I'm going to tell you A and C have the same measure, B and D have the same measure. I want you and your groups not to come up with one, but two true statements using substitution right now. Okay? Using those three, come up with two new statements using substitution. Give you 2 minutes. Go right ahead. I want two true statements now using substitution. Okay, I think we got at least one here for me. At least one true statement. Who started us off, Doyle?
Angle C plus angle D equals 90.
Good. Angle C plus angle D equals 90. We did a little two substitutions there, right? We took angle C, plugged it in for A, and we took D and plugged it in for B. All right, well, maybe I don't need to do two at the same time. Maybe I'll just do one. All right, and give me one statement now. Another statement that must be true. Ho, 15. Gabby. Awesome job. Angle A plus angle D equals 90. Anybody have down angle C plus angle B equals 90? That's also true. Leave it. Okay, so that's substitution, right? And let me give you a little tip that you might want to jot down here. How do I know substitution is going to be involved when we start these proofs? You are going to see repetition What do I mean by repetition? Look at my first example. Everyone see a line segment that repeated? AD. And in the second one, everyone see an angle that repeat, or actually two angles that repeated. Angle A repeated itself and angle B. So that clues me in that substitution is probably going to be needed when I see repetition of segments or angles. Don't forget that. Okay, if I see repetition of any segments or angles, probably some substitution time. So some things to help you out so far. Reflexive, we're going to let that sit for a little bit. Substitution, and the final one that's going to help us out in proofs. Addition. All right, don't draw anything, please. I just want you to show you up here on the board how addition works for you. All right, so I have 4 line segments up here. I'm going to call the first 2 A and B, the second 2 C and D. I will tell you that A and B are congruent and C and D are congruent. And we are going to pretend I have all 4 segments on your desk right now in your group. And here's what I want you to do. Ready, kids? I want you to take segment A, attach it to segment C. I got a longer segment now, don't I? Yes? All right, leave that there. Then I want you to take segment B, attach it to segment D. I got a longer segment again, don't I? What do you know about the 2 segments that are sitting in front of you right now in your groups? They're what? Go ahead, guys. They're what? Congruent, right? Everyone agrees that those 2 have to be congruent. Why? Welcome to the addition postulate. All right, here's what it says. If you take 2 pairs of equal quantities and put them together, the results are equal. All right, the results are equal. So in this example right here, I use segments as A, B, and C and D. You guys just told me that, hey, when you put A and C together, A plus C, it's going to be the same length as if I put what 2 together? B and D. This is called addition postulate. Not done. You and your group, 30 seconds. Come up with another combination I could add together by the addition postulate, and they would still be equal, other than the ones I just used here. Got another possibility I could add together using addition. Oh, one more time, Gabby. Fine with me. A plus D equals C plus B. Good work. All right, before we move on, at any time this year, you respond and say, I want to use addition postulate. I will respond with the following question. How many pairs of equals do you have? All right. You are not allowed to use the addition postulate unless you have two pairs of equal quantities. Now, kids always, I don't get it, but kids get confused when I say the number 2 and the word pairs. Here's what I mean by 2 pairs. 1 pair, 2 pair. You have to have 2 pairs of equals to add together. All right, so be ready for that question in return from me today. How many pairs of equals do you have? Because you can only add if you have 2 of them. All good. Before we move on, you might want to take a deep breath, stretch out if you need to, because the moment is here. You are about to do your first geometric proof of your mathematical careers. This is a huge moment. It ranks right up there with probably getting on, if you took the bus, getting on the bus first day of kindergarten, and you're taking your pictures and everything. This ranks right up there, everyone. Okay? Middle school graduation last year ranks right up there. All right, your first geometric proof. We ready? You good? I'm glad you guys look so excited too. All right. First, before we dive into the proof, elements of a proof. All right. Number 1. This looks familiar, right? I'm going to give you information that's true about the diagram. You will always be provided with that. I will give you a diagram. First thing I want you to do, same thing you did for me yesterday, which was take the givens Mark them appropriately on the diagram. So what can I put on A, B, and D, E right now? Go over the diagram and I can plop what on there? Oh boy, come on, we've been here. Hash marks, yep. So everyone go ahead. A, B, and D, E should have hash marks. Oh, I gave you a second given though. B, C, and E, F, what should I put on those? Hash marks, but probably not singles, right? Because not all four are equal, but I should probably put some doubles there, right? All right, so givens, mark your diagram. Then you should go right to statements, reasons. And you're welcome here because I wrote them in for you. If they're not there, let's write them in, okay? That's always our first statement, along with given as our first reason. So write those in. All right, here's the new part here you're not used to, and that is this. I am always going to ask you to prove something is true. So I am asking you guys to go from these givens and somehow use them to show me this is true. What goes in the middle? Your knowledge of vocabulary and the three things that are going to help us today. All right? So how do I get from these two line segments, these pairs being equal, to A, C, and D, F being equal as well, and how do I write it? Okay? That's a proof. That is a proof. The proof statement, finally here, the proof statement, that's your last line in the proof. If your proof is 6 steps, step 6 is the proof statement. If your proof is 3 steps, number 3 is the proof statement. This is your last line in every proof. All right, so let's talk. How are we going to get there now? All right, how do I get from these bad boys being congruent to AC and DF being congruent now? Okay, look at the diagram. What am I going to have to do to these two up here I've marked to get to AC? What's it look like I have to do to them to get to the full line segment AC? I got to do what? Put them together, right? Add them. Everyone, yeah? Add them? What about these two? What am I going to have to do to these two to get to DF? Add them? If you want to add, how many pairs of equal quantities do you need then? 2. How many did I put in the givens? So we can add right now. Okay? That's why I keep asking you how many pairs you have. So in statement 2, we have enough information given to us to add them up. Now you just got to put the right pairs together. So give me one pair you want to add together. One pair you want to add together. Oh, Gabby, you're on fire today. Okay, ready, everyone. AB added to BC is equal to, what other pair am I going to add to it? All right, AB plus BC is the same as if I added what other pair? 6, there we go. Thomas?
DE plus EF.
DE plus EF. Don't make up something. Use something we've talked about. Why? Why is that true that we just wrote that? What gives us the right to put that down? Don't make it up. Something we've heard. Gianna, yeah? That's something is equal to itself. What are we doing to these two, John? What are we doing to them? That's it. Yeah, right? Addition. Add a pair of quantities, set it equal to another pair. Perfect. So this is addition. And no, I don't care if you write postulate or not. Addition is fine. Are we okay so far? Why I can add them? Because they're both equal to each other. That's not my proof statement, though, so that means we got to keep going. AB plus BC. Anybody got another name for that? AB plus BC. What can I put in instead of doing AB plus BC? What other name can I give that? Go ahead, Gabby. AC. So I'm going to replace. There's a hint coming up. Replace it with AC. And what can I replace DE plus EF with? Ones? Will? What can I replace DE plus EF with? DF. Why? I replaced it. See? So that is substitution. Yep, everyone see? Substituting in what it's equal for. Questions? Now I'm going to vent a little bit here. All right. I really don't have I'm kind of in the middle on this whole pouch thing, putting your phones in the pouch. I'm kind of in the middle for and against for reasons. But one reason why I'm very against it is every year at this time, I'd let all my students take their phones out, take a selfie with their first proof, or get a group picture together with their friends, post it on your socials, your IG or your stories, and get a whole bunch of likes. Can't do that this year. Can't do it. So sorry, guys. Sorry, because the pouch is there. We can't celebrate it as much as we want, but maybe after school, if you want to take a quick pic with your first proof ever, go right ahead, okay, and keep celebrating. This is a big moment right here. Congratulations, everybody. Bad news, though, this is your first of like hundreds that we're going to do this year, all right? And I'm not exaggerating, hundreds that we're going to do. So congratulations on your first proof, everyone. Congrats. But unfortunately, one does not make you great. Let's keep trying these out. All right. I'll let you guys start it off. Read your givens. Read your givens. Mark your diagram. Put them in your proof. And then we'll talk. Joel, do not mark the proof statement. That's only going to get more confusing. Never mark the proof statement. Always the givens. So we put hash marks or arc marks on this diagram. Arc marks, they're angles, right? So I'm interested to see. I'm going to walk around just to make sure you guys are marking the right angles congruent. The correct angles. And then make sure it goes into number 1. Looks like you guys are pretty solid on marking them. That makes me happy. Again, do not mark the proof angles. That's not true yet. We got to prove that's true. Go ahead, copy it down into your statements now. All right, everyone, ready? Look at your proof statement now. Angle ADC. Everyone identify where that is. No markings, just identify where ADC is. We need to show that's congruent to ABC. Identify that angle. All right, everyone see where ADC is? And I'm just going to put, don't do this on yours. I just want to make sure we're all good right there. There's ADC. Don't you have 2 angles marked right there? What am I going to have to do to those 2 angles marked to get to ADC? What do I need to do to those 2 to get to ADC? Add them together, right? And the same thing applies up top. I'm going to need to add those 2 to get to ABC. Oh, we'll stop. You want to add? You want to add? How many pairs of equals do you need? How many did I give you? Okay, you've been lucky so far. That won't happen next proof. But all right, so we can add in step 2 now. Now we're just adding angles instead of segments. All right, give me the angles you want to add together. The correct pair to add together anyway. Ooh, 5 spot. Haley, hello. Okay, there's the first one. ADF added to angle EDC. Good work. Equal to. What other pair am I going to add together here? 15. Gabby, come on now. Here we go.
Angle CBE and angle ABF.
On fire. Good job today. And why can I add those together again? What gives me the right to? Ones, Will? addition postulate. Good. And now I need to replace it now, right? I need ADF plus EDC. Replace that with what angle? What's the same angle as those two added together? Oh, there we go. 4, Doyle. What's up? ADF plus EDC. I can replace that with angle.
ADC.
Good job. Yeah. Be confident. Don't question yourself. And then CBE plus ABF. CBE plus ABF. What can I replace that with? 6. Thomas? CBE plus angle ABF. These two up here, basically. These two right here. I put them together, and what angle do I end up with? ABC, yep. And all I did was substitution. Okay, a couple things. I'm getting you guys in bad habit because you guys are going to think all these proofs are just given, addition, substitution. That's what you're always going to think. All right, I need to break that bad habit right now, though. All right, let's break that bad habit with example 3 and show you it's not always going to be those 3 in that order. So do your thing, mark it, write it, mark it and write it. Got a bad habit going now. Let's break it. Got some hash marks on those segments, hopefully. What's up?
How would you mark the second?
What's that?
How would you mark the second? Because when you're doing the same.
What do you mean the second one? There's only one given.
Oh yeah.
The other one's approved, right? And we don't mark the proof. We're trying to, right? Everyone sees you guys have that, right? Proof. Yeah. Okay, that's what we're trying to prove. So we're not marking that. Hey, I know you guys are used to it. You're in a bad habit. I only have provided you with one given here. That's it. Just the one given. All I know is segment DE is congruent to segment BF. That's all I know. All right, you ready to help me out? And I can already tell some of you guys are getting in another bad habit on your, and I don't care what you do in your notes or on your homework, but when it comes quiz and test time in this class, we number our statements and reasons, please. Okay, some of us are getting away from that. I don't care what you do or for notes and homework, that's not my business. But for quiz and test, when you hand it in, everything better be numbered so I know what statement goes with what reason. All right, guys, here we go. You know that DE is congruent to BF, but I need DF and BE equal. How am I going to get those equal? Well, let's start here. Everyone take a look at segment DE, and you need to go to what? DF, right? Are you getting bigger or smaller? Is that segment getting bigger or smaller as I go from DE to DF? Bigger. Only way I get bigger is if I add something onto it. Agreed? What do I need to add on then to get there? Take a look at your diagram. To DE, segment DE, what must I add on to it to get DF? Dave, go ahead. Everyone agrees EF? I'm just going to jot, and don't do it. You don't have to. I'm just jotting down I got to add EF. Because here's why I'm asking. You want to add? How many quantities do you need? But how many did I provide in this problem? So ready? In step 2, we cannot add right now. Does everybody see that? I'm going to add DE and B. DE to what? I don't have anything to add it to. So you can't add in step 2 just like we did in the last 2. Are we clear there? All right, so we got to keep going. Now take a look. BF to BE. BF to BE. What are we adding on to BF to get to BE here? 3. In?
Yeah.
And what? Go ahead. Again?
Yeah.
I heard you. I meant like again, like yeah, again. You're good. You're good. You're good. So to both of those in the givens, I have to add EF. What do I know about EF and EF? Yeah, what do I know about line segment EF and line segment EF? Because of the reflexive property, they're equal. So how is this weird property going to help me out? It's going to get my second quantity to add. All right, because everyone agrees I only have one quantity right now. Where's the second one come from? EF congruent to EF. And why is that true? Because of the reflexive property. Yep. That's where you're going to start using reflexive. Now, how many quantities do I have? 2, and now what can I do to them? Add them up. Yep. So you cannot add unless you have 2 of them ready. All right, give me 2 you're going to add together. 1, Charlie, give me 2 you're going to add together.
DE plus EF.
DE plus EF is equal to, give me the other pair we want to add together. Good job today, 2. Zoe, hello. Good job. BF plus EF. Why? What's my reason here for number 3? 13, why can I do that there? K-Dog. Good. And then, yes, this is a pattern you can establish that anytime I write the word addition, automatically next step will be substitution. That's an automatic all year long. To write in DF congruent to B. You can't add unless you have 2 equal quantities, and if you only have 1, where's the second one probably going to come from? And also, too, to mention, reflexive can also be used on an angle. Okay, an angle can be reflexive to itself if you need to add it. Please go to your homework. I want to make sure we are clear on a few things so there's 0 confusion tonight and 100% success. Please don't start doing it. Just let me talk first. 1 through 4. All you're writing is which postulate or property are we using from today. Okay, so your answers for numbers 1 through 4 should either be reflexive, substitution, or addition. Good. Starting with number 5, notice the directions say write a formal proof. Starting with number 5, that's when you do statements, reasons, write it all in, number it. Okay? Last thing, look at number 5 for me, please. Everyone look at number 5. Because I think some of you think that every proof has to have addition in it. No. No. Every proof does not have to have addition in it. Here's why. Look at number 5. Look at what I've given you. NP is 2 inches. QR is 2 inches. All right, so 2 inches, 2 inches. Why would NP be equal to QR? You're not adding anything here, right? You're not adding anything. How can I go right from here in the given step 1 to the proof statement? What am I using to say NP equals QR? How much does QR equal? 2 inches. So anywhere I see a 2 inches, what can I put? What am I doing here? That's all it was, substitution. All right? Every proof will not have an addition with it. Does everyone see? And, do I still have it up? I probably do. Remember I told you to look for repetition. I see 2 inches repeating. Hey, let's skip down to 6 real quick. What angle's repeating? Probably just a substitution then 1. All right? Every single proof will not contain addition. All right? It won't. All right? It may just be plain old substitution and I'm done. Oh, good. See what you can do on your own now. Go ahead and work with each